Bueno, vamos a continuar.
Let's continue with our tutorial.
¿Mm?
Bueno, continuamos entonces.
Okay, so we'll continue. Let's recap a little bit our last session. Well, Erica explained origin validation. So, how it works in terms of our RPKI, we need to create the ROAs. Normally, you'll do it on my LACNIC system. The resource administrator will create the ROAs, as we said before. The models based on who's been assigned the IPs, that is who will create the ROAs and has to define which origin systems will assign the prefixes. So once we've created the ROAs in the MyLACNIC system, that information together with the cryptographic information will be sent to repositories, those repositories on LACNIC, and we have one in each of the regional registries, ARIN, APNIC, CRYPTE, and LACNIC. So those repositories are publicly accessible. That will download that repository, will download it from each of the regional RIRs and from each repository, and will validate from the cryptographic standpoint, and after that we'll have a list of prefixes with autonomous origin system and the maximum length for disaggregation of that prefix. That is quite important. If you remember our first example with a /40, and then another one was announced as /48, that would beat our prefix because it's more specific. So the possibility of having the maximum disaggregation length for that ROA will allow us to have, I have a /40 and I will disaggregate up to 44. So if someone publishes a 48, that would not be valid. So that's what we discussed earlier. What we will see now in our demo, I have a Fortis validation installed in my virtual machine in my laptop. So that Fortis validator is one of the RPKIs most widely used. And what I will show is basically the list of ROAs that's being created and some additional information, but I will explain it as we go on our demo. You'll also see this in the afternoon. You won't see this validated in so much detail. You'll probably use it more than anything that is afternoon. Now, to finish explaining what we're saying about the ROAs, we will see what we can have in the validators and how the publications look. So the first thing I'll show you is a minimum settings or configuration file for the Fort validator. We have not yet seen what different validators we have, but this is one of the most widely used in the region, as I said before. The configuration file is a one-line file. What's more important is the indication as to where it stores the files for the 5 registries where it will go retrieve. This is a folder in your local machine, in your server. You will find the information. Then the local repository where we'll download the data and where it will be stored. And this is the part that I want to focus on today, is where it's a file where you can keep in a CSV format all the ROAs and the information that the validator generates. So remember that one of the main objectives of the software and the validator cache is to retrieve locally the information for the certificates generated in the repositories for each of the local internet registries. As we can see on screen, we can see the cross anchor locator, the files retrieved locally that have the certificates that we will list in CSV format. These are the 5 tanker locator to show the root for the 5 registries. There's no one single root. As you can see, there are 5. Each regional registry has that RPKI, and this is just, well, information for, well, validation and software, so you can see the data, signature, public key, the certificate, where to retrieve it, and so on. The repository is not large.
Donde se guardan una vez que...
So once we retrieve the information, this is where we'll store the information locally. We'll copy the repository for each one of the RIRs and store it here. These are the directories. Well, for example, LACNIC. So we'll retrieve a lot. Well, you can see how long it takes. If you wanted further information about what each of these things means, you can reach out to Gerardo. He's right here at the front. He implemented this in LACNIC. So we are looking at it from a network operation perspective. He looks at it from a software perspective, so he can explain much in depth what we can find in the repository. So earlier we mentioned LACNIC's autonomous system, and the ROS file, the .csv file, shows a list of the autonomous system, the prefix, maximum length, and here's a very long list of ROAs. So autonomous system 44812, prefix 1140/24, maximum length 24, and so on. There are many, many lines. There are 775,000 entries. So of course we're not going to go one by one. We'll just look for some. For example, LACNIC's. So all of these entries are the ones the router will learn. I mentioned earlier the connection that the router establishes with the validator, and in the routing table we'll find additionally the set of information for the autonomous system, the prefix, and the maximum length for that prefix. So all of the entries that Guillermo just showed are the ones that will be able to retrieve and aggregate the validation attribute within the table. So this runs in an external server using the RTR protocol to communicate with the router. The router will have this information. The router will do nothing from a cryptographic aspect. It will not run any processes. The validation process will take a couple minutes in the server. That's why it might overburden the server. That's why it's external. But the router will have or keep this table, which is what we want from a validation standpoint. Now I look for the ROAS in the autonomous system 28,000 that belongs to LACNIC, and this is what we can see. We have, for example, 2801, 165/56, and with a maximum length of disaggregation of 64. So in that example, the autonomous system 28,000 originate network 165 with a 56 to 64 length, or this one IPv6. It says /23, but it can be announced in /24 or here 2224. And this is very important that you do it as is, as you are publishing your networks. If you are publishing prefixes, well, summarized prefixes, you just use that one. For example, /22, 22. Now, if you're publishing disaggregated network, because you have different chunks, you'll have to use this, or one per prefix. For example, let's suppose that 22 is published in 23 and 24. Well, we might have that entry as it is here, 22, 24, and it'll include 22, 3, and 4. Or you'll use all this /24 that will be published. But it's important that you do it that you create the ROAS as you do the publications, because if you create ROAS that are only /22 and you publish as /24, those GB announcements will be invalid. Yeah, we can look at one of the SANs that are left. We'll do the query with one of the ASNs that were sent remotely. We'll query ASN, the ASN sent by Henry Galindo, 269867867. So 2698667 has two ROAS. The first one from an IPv4 address /24, and the second, it is 2801 15,000/48. So actually it's almost the maximum length, these specific prefixes. The ASN sent by Jose Velez, remote participant, ASN 27297. So we have four ROAS, 27297. One ROA for this IPv4 range, it's also 24. Another IPv4 24. Another IPv6 2803 C710/32, and the disaggregation maximum 48. Usually 32 blocks are from ISPs that disaggregate those blocks and deliver blocks that could be /48 to their clients. But here it is possible, this ROA, it's makes it possible for that 272097 originate not only a /32 but more specific blocks like a slash up to a /48. It could be 40, 36, so on. So anything in between. And the last one is an IPv4 address. Since these are /24, there's not much disaggregation. Yeah, we can show. Yeah, you can go ahead. So now we are querying the validator from the validator directly. We are validating that list of entries that we have specifically for these ASNs and to see which row has been created for each. And we have different tools to validate or to visualize actually the status of those segments, and that can help us know or to retrieve information in detail as to how to create those certificates when we need to create them. So our different tools like Looking Glass, where we can query by ASN and we can see the status of our publications and see where we can retrieve information to generate our ROAs.
Or we can also do the queries with these tools to see that, in fact, this is viewed as a valid state, or that we have segments that we didn't create, for which we didn't create the certificate and appear as not found, or if some of the certificates that we created has changed and we generate a ROA and a certificate referring to a segment, to a prefix, then that prefix was disaggregated and was published through another ASN, and we didn't create that ROA, so we are invalidating that route. So if this appears as invalid, we can check that with that tool, with using some of these tools. This here is a fault monitoring tool that allows you to enter a prefix or an autonomous system to view the publications in real time. This takes the global internet tables and compares this against the ROA information. So this is also available in Spanish, but here it's in English. You have technical reports. You can go there and do a search based on the prefix. So this is one of the networks that you gave us just now, 188.258.0/24. I looked that up, and it shows me the ROA information. The RPKI validity state. And just a detail over here. This is a /24, which is cable TV with CAT TV. You recall that we said this is a /24 with maximum disaggregation of 24, but it seems that this is part of an 18 prefix with either Trisel or another might have, and this has been subassigned. Now the important thing is that the ROA was created with a /24 and the publications. This takes the latest date, this is October the 5th. This has been published as a /24 with the origin autonomous system. This over here is taken from global BGP tables. So this is no longer ROAs, this is BGP. So it looks up the RIPE areas and route views looked up that shows how this has been published with this origin AS. They check that it's valid from the standpoint of RPKI.
Y acá tienen para
And here you have a couple of days backwards if you wish to check that out with more announcements. Now the important thing is that you can check this what you showed as an autonomous system. We looked up the ROAs. We saw the ROAs that had been created. So using this tool, I can look up something different. I can look up my networks and see if they are valid. And if you haven't created the certificate, it appears as not found. So we would visualize the important information that we require, namely with what autonomous system each of these prefixes is being announced, how the prefix is being announced, and obtaining the information in order to generate the certificate, in order to generate the ROA correctly. In doing so, once we go back to do the query, once this is generated in the MILACNIC system, and we repeat the query using this tool, it should have changed status from not found to valid if we generated this correctly. Over here, we see this by prefix and by autonomous system. Here I check this through autonomous system, and if I put 28,000, which is a LACNIC number, it shows me all the announcements made by LACNIC and the validity status, the prefixes, the autonomous system, and the status all appear as valid, RPKI valid. So we're going to check the one from RIPE and Hurricane Electric. RIPE start. So let's look up the one of Hurricane Electric. This is another tool that you can use. The fault monitoring tool is one that we developed at LACNIC that allows you to see those kinds of things, basically for prefixes of the autonomous systems of the region. It has one part that is good, which is like a summary or an overview where you can check this out country by country, what is the RPKI deployment they have. This tool is a Hurricane Electric tool. It produces these graphs on connectivity. You see who are the providers of the 28,000, which is LACNIC. You see all the upstreams, how they are interconnected in IPv4 and on IPv6 and so on. Over here, if you put check in prefixes, it will show you which have RIR validity and which have not been created. This one over here, I don't know why it doesn't appear. The ROA has been created, but it doesn't see it. It doesn't have the visibility. This is a different way of viewing the information. You can use the one you find more useful. And RIPE-STAT. So over here, for example, I enter this IP over here. So we're going to do the query. If with the people who are following us remotely, or if anyone wishes to go up to the microphone, we can check out some of the autonomous systems that you can let us know. We're going to check the AS266783 of Fernando Leon. So let us check the routing part. You have a lot of information there, much more information that you can check out over there. It says that it generates 8 IPv4 prefixes, then IPv6 prefixes that are generated. And over here, you have part of the history of each of the prefixes.
Cuándo se empezó a publicar, cuándo se dejó de publicar, con qué sistema autónomo y demás.
And somewhere we'll be able to find, I think here at the bottom, right here, we have each of the prefixes where they are announced in BGP, RIS, if it's in RIPE. Well, this is designed in RIPE, so they'll check whether it is in the RR, ours in our region and no longer here. If they are in a different IRR published, and then the little smiley indicating that it is valid from an RPKI standpoint. None of them are invalid. So those tools are also present in our presentation, so well, they're right here for you to have. So these are the validators, yes. So to wrap up our first section, we'll show some of the more widely used validation software in the implementation of this validation structure that we discussed when we started with the RPKI topic. Right here. Okay. So as I just mentioned, Tito just mentioned the more widely used in our region. The most widely used is the Ford validator. It was developed by LACNIC together with NIC Mexico. And this includes the validation software that we will install in a server, our validator cache, and we'll query the other RIR repositories, develop it to the router, and we also have the Ford monitoring, which is one of the tools that Guillermo showed for queries. Another very widely used is Routinator 3000. All of these software serve the same purpose. These are open source software that can be installed in a local servers on premise, and it will be the validator cache, and depending on how we configure them, they will query the repositories, retrieve it locally, and deliver that information to the routers as part of the good or best practices and recommendations about whether we are implementing and validating structure. Is that we have two different software in case one fails at any point. So to have two validating caches with different software operating, and whenever something happens to one of the software, the other will take over. So for those who have the need to run these validating schemes, so to set up the origin validator and have a validating cache, receive the information from the route and deliver it to the router, well, remember that at some point I mentioned that in the RPKI we spoke about the responsibilities. One is that all the prefix owners for the IP addressing are responsible for creating the certificates, the ROAs. But now if I am an end user, an entity where I manage my own resources, but I am not interconnected to different networks, I do not receive information from networks from other autonomous systems. I only publish my own information through an internet service provider. By creating my own certificate, I am already fulfilling my responsibility and doing my own part in showing or indicating others the resources that I am publishing, how I am publishing. But if I am an internet service provider that receives a very large number of routes from different autonomous systems, I have different interconnections, transit, period connections, well, in that case, we would need to go ahead and implement a validation infrastructure. So from that full routing table, we can see what is the validity status of all of those networks. And based on the validation status, we can carry out specific actions as to what to do with the valid, invalid, or prefixes that have not been found. Of course, the valid will continue to be routed, but what would we do with the invalid prefixes that we are receiving? Are we going to filter them? Are we going to let them through? Or this way of visualizing it and having that information allow us to use different mechanisms to automate those actions, and that's what we will see in the afternoon tutorial.
Respecto a eso.
So we will be able to do filtering based on that. Regarding the infrastructure, if we speak about the infrastructure of a provider of a traffic exchange point, you have several ISPs and autonomous systems that all announce their own routes. The IXP will also have to have that role of monitoring this and doing out the filtering. So it is also important that we are clear of the infrastructure we have, if it is only necessary to generate the ROAs, the digital certificates, or if in addition to those, we need to implement the validation infrastructure in order to monitor it. So here we leave information and documentation on the Fort validator. So you can download the validator and follow the video step by step to see how it can be implemented, as well as the documentation you can find in GitHub to see how this validator works. This slide shows some of the useful tools for monitoring these certificates and also on the validation. We have mentioned the validity status of a route, and this depends on how you generate the ROA. If I have it generated properly, it appears that not found. But if I did generate the certificates and there have been some changes in my publications, in many cases, we not only operate the network, but you have an operations group that segmented a network. It was assigned to another autonomous system, or if it was segmented and still is published, but because it was segmented, smaller prefixes are published and the row was not generated. So in that case, this appears as not valid. So in the network, you sometimes do changes and forget to update the information, which might lead problems of accessibility to the networks, or if the information goes through some of those networks that do origin validation, they would be then filtered out. So we need to have tools that allow us to visualize that, to automate the verification process for the rows, and to receive notifications if anything changed so that we can take action. So we have these tools here, BGP Alerter and PacketVis. These two have the role of forwarding notifications in order to monitor the status of our route to see if they change. And the difference is that the BGP Alerter has to be downloaded. It's an open source, and we have to install it in a server in order to set it up and establish the monitoring system. PacketVis is a web tool where you register an autonomous system that you wish to monitor. We're going to define how we will be receiving notifications, whether through Slack or through mail. whenever there is a noticeable change or some type of incidence or update regarding our autonomous system, so that we take action in that sense. These are tools used globally, and if you manage different prefixes and different autonomous systems, will give you the option of defining that monitoring scheme and automate the information so that we don't depend on entering these tools manually to check the validity statuses. So we can trust that we can receive notifications and act accordingly if some changes took place in the publications we do on BGP. If you wish to have for more information, these tools and also everything that we'll have will be around throughout the event. So please, we'll be around. We can discuss these things in details if you wish, and how you can create ROAs and so on. So we'll be around. So we're happy to receive anyone at the booth. These are the tools we used in the presentation, MILACNIC, where you create the ROAs. We have MILACNIC tools, fault monitoring, RIPE, RIS, hurricaneelectric.net for BGP. And in the presentation we have, on the event website, you see the link to access these tools that can allow us to do those queries. Now, in addition to that, let me remind you that the virtual campus of LACNIC organizes courses that are focused on the use of routing security with RPKI and RIR. So these courses are free of charge for all LACNIC members. We have a calendar. These are the context of specialization activities that we have. These are free courses. You have to register, and you can find more information on LACNIC campus on this website. So, recap of what we have seen today. How to consult the RIR. So, what we saw then, recapping on what we covered today, and this would be the end of this first session. We saw our RIR and how to do queries to the IRR. This provides information when we have to do BGP configuration. And we have to configure the filters on the beginning, on the entry, or if what is being announced is correct or not. Remember the first example we had in the morning, where an autonomous system hijacked a prefix because we couldn't determine if we had to accept it or not, depending on how it was announced. So how do? We consult the RIR. We do very simple queries. We use BGP Q4. We saw briefly how to create the objects and MILACNIC. This is generated automatically through RPKI. And the links in the presentation shows all the specific information as to how to create those objects. And then validation of origin, how the validation infrastructure works, origin validation infrastructure works, how the connection is between the validators, the validating cache, the routers. We explained what to take into account to create ROAs, the role of the validating caches, the software we use. We made a demo from the fault validator, the queries, the information that the validators have that deliver to the routers, as well as some tools that we shared with you for queries, tools containing information to check how we are publishing things, the status of our prefixes, as well as other tools that will help us to automate the monitoring process and send us alerts if any changes occur as regards the publications done by my autonomous system, or if there are any changes to those prefixes that I'm publishing from any other autonomous system that I have created. Any questions? Questions, comments? Well, we have a question. And if you answer correct, you'll receive a prize. I'm going to ask another question. And there's another prize. If are there any questions from the remote participants? And we'll now proceed to ask the next question. This is the question for the in-person participants. If you have the answer, you can come up to the microphone and read the question carefully. This is the question. I am a provider that has the network 2001 DB8/32, and I have an ASN 65000. I have a client who I assign a segment of that 32 segment, which is segment 2001 DB8ABCD/48. This client, in addition, has its own autonomous system, which is 65002. That segment, which is a /48, is published in ASN 65002, which is a customer's one, but it is also published by ASN 65000. Which is my provider, the one who gave me the /32 segment. It also publishes the /48. So what ROAs should be created and who should create those ROAs? Read it carefully, think about it, and if you already have the answer, go up to the microphone in the aisles. Remember that we are asking what ROAs should be created and who should create those ROAs. So we can discuss this. Those who have any objections regarding the answer to what the participants say, and then we can have a discussion. There we have someone. A possible winner. Let's see. Name? Fernando Calderon from Fibercom and FiberNet. First, the user should create it, the one who has the /48. The user should create the /48 ROA to publish it. So first, it would create that. The owner of the ASN 65000 would create the /48 in order to announce that prefix to the world. And then Come on. And quite obviously, the provider, the owner of the /32, should create a ROA /38/48 to determine the prefix length, which can be to disaggregate the large prefix. And the two ROAs have to be created by the client or by the provider. One, the owner of the largest prefix has to create it. Anyone else who would like to comment on that answer? So far, so good. Hi, good afternoon. Name? Willy Buitrago from Colombia. The provider is the legitimate owner of the /32. Therefore, only the provider should do that, not the client. And what ROA would it create? The /32 and /48. And from what autonomous system? From 6500. 65,000. Only from both autonomous systems. All right. Anyone else? Guillermo Zapata. I'm from Intel Chile. From my standpoint, ROAs should be created for the two cases. 65,000 should announce the /32 ROA, and the clients that has the autonomous system 65002, which was assigned the /48, should also create a ROA so not to create a conflict in the assignment of the validations to be done by an RPKI. And what ROA should the ROA /48 65002?
Bueno, ¿hay alguien más?
Anybody else? That is correct. That is correct. Yes. The other one is 326500. The two ROAs. One's the client, the other one's the supplier. Who creates 48 with 65,000 and 48 with 65,002? Well, the second is by the client and the other one by the vendor. Okay, the last one. Hello, I'm David Bayo. I'll take a leap of faith here. Opposite to my colleagues, I believe no ROA should be created since this is an autonomous system. Okay, great. So you got us. But in this example, let's just assume that they are public, that will create the ROA. But of course, they're private, but this is just for documentation of autonomous systems. But we'll give you a prize. We'll give you a prize because you discovered it. But oh well, we'll give the prize to, well, actually, yes, all of you. You all sort of complemented each other's answers. We believe the first one. If you can please come to the mic. What was your name? Fernando. Okay. So he was a bit closer to the answer, the correct answer. And in fact, it is the vendor who has to create the ROA for that segment /32 with the announcement from the autonomous system 65,000, and then it is the client who's responsible for creating their ROA for the prefix 48 announced from 65,002 and prefix 48 announced from AS 65,000. Remember that as part of the information that we provided, we explained the policy that started enforcing 2023 and the possibility for clients to create their ROAs or their certificate by the sub-assignments. Otherwise, the full creation should be done by the client. But now, since prefix 48 is assigned, the responsibility is for them to indicate for prefix 48 which autonomous systems will allow transit. This is autonomous system 65,002 allows also 65,000 to transit, and the vendor will generate the ROA for segment 32, right? So the other participants were right in what they said, but they just missed one more detail for the correct answer. So we'll give Fernando, the first respondent, the prize. The answers were right, but as Erica said, the policy that was defined not long ago, it was originally the owner of the block, the 32, who was able to create both ROAs. But now the policy says that if the vendor has delegated that block to another operator, that second operator can create the ROAs and will be able to do so, well, in this case, the one with 48, if the operator who has the 32 has delegated upon them that block. What is important is that if you have a block that is published with two different autonomous systems, you have to create both ROAs. Otherwise, one of the two will be invalid. If you only create the ROA for one autonomous system, the other one will be deemed invalid. Okay, we're good so far, I think. I do have one question. Why, if the client will create a ROA with an autonomous system that does not belong to them, is that what you said? No, there could be, I mean, we can find anything online, but there could be cases of an organization that would like to publish a prefix with an autonomous system and a different one elsewhere for whatever reason. The example is just illustration purposes, but if you no, I mean the question. If I look at the aspects of the autonomous system or the prefix, the /48, the originator is 65002, and it goes through 65006, the vendor. No, it was originated by both, actually, by 65,000 and the same prefix originated by 65002. Right, that is my question. So I would need to know that the vendors also announcing it from their origin, and I should create the ROA. You're the owner of the resource. You will grant authorization to autonomous systems to publish in your segment depending on the connections that are available, or they might be publishing from another point depending on the structure from the ASN directly from the vendor and maybe not from your own ASN. The publications from the same segment might be done from different autonomous systems, and since you are the owner of that resource and it's been sub-assigned, you are the owner of that /48, you are the one that gives the whatever autonomous system to publish or to originate it. But in that case, if the vendor assigns it to me as my own resource, or it's sub-assigned to me, I would it's not clear to me who's responsible here. I am part of a service provider where we do that. We do resource allocations, and I have not found in validating our prefixes online we can see there are prefixes that are assigned to a client but do not have a valid ROA. So internally, we think that the responsibility is from the client, but the origin of the prefix of the autonomous system belong to the client. We are not going to make the announcement. It's just in transit. Okay, but it's correct. In that case, you are fulfilling the transit and it's originated from the client. In our example, we have a client that might be publishing with two different origin autonomous systems besides this vendor. We just use the vendor to make the example easier, but the client might have two autonomous systems because they work in two different countries and they have to create the ROA with one autonomous system belonging to one country and the next. Right, but what you're saying could be true. I could have an IP and I will route it from two different IPs, but in the example, it's still not clear to me. Exactly because of that, I cannot see how, as a client or as a vendor, I will have to announce it myself through my autonomous system also. Only if you, as a vendor, for whatever reason, announce it with your own autonomous system as the source system, not the transit. So if you are further right in the ASP, so for whatever reason, maybe your topology or whatever reason forces you to publish it with your own autonomous system, not using the client's. Right. So I would understand in that case if I use it as a vendor, if I don't delegate it, I don't take it out, it might cause a problem at the announcement level. Because if I delegate the prefix to my client, I don't need to announce it as having my autonomous systems at the as the origin. No, I know, it's just an example. It's not a real case. It was just an example to see how if a prefix is published by more than one autonomous system, and that autonomous system, well, who would have to create the ROA in that case? So if I have delegated a prefix and I know it'll be published with my autonomous system, but there's somebody else who will publish it as well, I have to create two ROAs, one for my own autonomous system and the one of that other part that will publish it themselves. Right. The example maybe is confusing. Right. It is confusing because I would normally have my own autonomous system and my segment, and I would have to originate always from my autonomous system. You're looking at it from the transit autonomous system standpoint. Right. Then the example would be different if the client has two outputs or it will be announced through two different autonomous systems. Right, it just depends on the topology because I could announce it with my source autonomous system, my network, but then there's another connection where for whatever reason or configuration or backup or whatever, it's been decided for the vendor to do it. Right, yes, that was what was not clear to me. If you look at the global routing system, there are many examples of this. A prefix that is published with multiple source autonomous systems. Actually, I believe that Alejandro is making a presentation on this. We are working on our PKI. We've done internal work. Yes, that is the implementation of everything. Yes, we validated, we implemented the fourth server. We're still validating. We are reviewing with the tool that you showed, and we found a case where we had a server provider, a Tel one, connected to us announcing a prefix from two different autonomous systems from different source system. One was our PKI valid and the other one wasn't. So we can find cases like that. Yes, it is a discussion that is really good for what we're saying, and you have to evaluate, well, whether it's valid, whether we need to filter it, because it seems to be invalidated. But it is correct that that announcement is being done, but then we need to look at the certificates. Right. We've also drawn the conclusion that there's a statistical side to analyze case by case what it's repeated the most. Yes, and that involves additional efforts. There's a whole lot of networks without information to make the decision on how to filter it. In Colombia, for example, in the internet change point, there's validation. Well, for many years now, as part of the monitoring efforts, they have found over 14% of the traffic, the prefixes are invalid. So they will report it and notify the owners of the segments and so on. They notify that the prefix is invalid, but they have not yet made the decision to filter it because it's quite a significant percentage. And many issues with prefixes are found that are being published by autonomous systems. There's an ROA created, the other one doesn't, but these are specific cases that the different owners have to report. Yeah, especially because of the mask. Yeah, the mask, of course, and how it's being published, whether it's being disaggregated or not. Yes, we've identified things like that. So what we do is a statistical analysis first. Yeah, well, at least you can visualize it. Yes, that is correct. Thank you. I don't think that microphone's working. Hello. Mario Kleb from DMKI Solutions Argentina. I have two questions that are combined, and I think that can help wrap up the concept. First, what does a router do when they found two different rows for the same prefix? Because maybe that can give us the answer. And then if I have a prefix /32 and I create a row with a variable mask /3248, and then I delegate a /48 to a different ISP, do I need to modify my original row so as not to include the /48 that I'm delegating, or nothing will happen with mine and then I will have to create the row for the other ISP with a more specific prefix? Well, the first part of your question, if you have two rows, the router will look at the announcement and if there's at least one row covering it. So if there are two and one of the two is covered and is valid, well, then it will be valid. If there are none, or if both covering, well, actually none of them validated, they'll be returned. If there's more than one row, there's no problem as long as one is valid. And in the second part of your question, yes, the client should, because it's a different ASN. You'll have row 32 to 48 with an autonomous system, but the others should create it with their own AS. Right, on the other side, yes, but on my end, I would not be, I wouldn't need to modify the row. No necessary.
Hi, I'm Celsa from NIC Chile. I wanted to refer to the comment made by Guillermo Zapata from Entel Chile. The work they're doing is quite amazing and great. When they speak about saying that they're doing statistics and analysis, it's not just statistics analysis. They're doing much more behind that. They did a sort of a BGP hackathon. They integrated groups from different areas. They had quite a great group of data analysis, and they started to analyze the BGP tables also from many years ago to analyze the Entel announcements in the BGP tables and to detect if they had misconfigurations or events that would have affected them. They also collaborate with the route collector in Chile. They contribute the full BGP to this route collector, and they're working intensively on the implementation of BGP, not only in Chile, but they're also trying to add Entel Peru, which has that RPKI also. But I invite you to contact him if you wish to check it out. We worked together when I worked with LACNIC for the Ambassadors Project for Research and Development. And what they're doing, I think, is great, and hopefully more internet providers could join the strategies that they are tackling so that the people who cooperate with them know more about this. Thank you, Celsa, for the information. Great. Yes, if they do it in that way, it's also very positive because it's not just on focusing on my own infrastructure and actions, but also about providing valuable information so that others can know more about these tools that we're sharing with you in terms of the statistics that you can generate, and also specific studies that are useful to visualize and also to understand all those cases and differences and the things we can read in those routing tables. Because, in fact, it is great to rate them with one status or another. So we already saw what we can do so far regarding the mechanisms we have, and to see how we can start to respond to incidents such as those that we described initially. We will now tell you what is up and coming at the IETF in terms of mechanisms that are also stronger, and for cases where the solutions we presented don't cover every single option. So we will now speak about new proposals and why these things occur. Now, what did we see all this morning? origin validation, the IRRs and RPKI. In that case, we only focused on the autonomous system that originates the prefix, but not all the path and if it's a correct path or not. We didn't analyze that. So we have a partial solution to the problem, which is validating who is authorized to publish a prefix, but that is not enough for the leaks, because if there is a route leak, the autonomous system of origin remains the same, but it goes through an autonomous system that should not be used. And if someone wishes to use a wrong origin, RPKI can be used for error configurations, but if you wish to do an explicit attack, they can also do so. There was a proposal as BGP SEC that was approved at the IETF. This was discussed extensively and became an RFC, but this was not approved by the operators. So this is what we were saying regarding route leaks. In the case of route leaks, 65511 continues to originate, and the path, the AS path, is the one over here, 65536. So RPKI doesn't solve this because the origin autonomous system is not altered, is not changed. So the ROA will be all right. In the case of route hijacking, instead of originating it through 65509, instead of doing so, it adds 65510. This will also work because I am faking the origin autonomous system. So if 65510 had created the ROA with some AS, I add an autonomous system of origin that is different from the path, and I publish it in this one over here. So this could end up happening. So this will depend on the filters and things that have been configured, but this could occur. So what other proposals, what other suggestions do we have? There are some cases that we cannot solve with RPKI. Well, on one hand, we have a classification of route leaks in the sense of an event becomes a route leak. And then we have the BGP roles, RFC 9234, which can already be used, and routers are already prepared to use these. Then we have other proposals that are newer, like ASPA, another one called assigned prefix list. Let us briefly look at these. Erica, you're going to speak about the route leaks and the announcements. I will briefly refer to RFC 7908. This is an informative RFC, and specifically it classifies the type of route leaks that we currently have based on the route leaks incidents that we have had globally. These are classified so that we can know which other segments that are published depending on the type of interconnection that we have, depending on the route that we have published, from what route we should learn from an AS to another, and also to establish which of these segments could be violating those policies, for example, the forwarder or the receiver, and so classify these in these connections and announcements that are made all along the path. As I said, this is an informative RFC that we have since 2016. RFC 7908 informs about the classification of the different types of route leaks, and also so that you understand which type of publications you have to make depending on the connections that we have.
These are the 6 types of route leaks that we have over here. A provider leak when a transit provider is made to another transit provider. What are the types of leaks that could occur in connections such as those that a transit provider should not be announcing to another transit provider? And also a lateral leak from peer to peer. This is type 2. Which announcement should be published? And then we have from a transit provider to a peer. This is type 3, and vice versa. From a prefix reoriginating the origin AS. So no solution would be found using RPKI. And finally, the accidental prefix leak and more specific prefixes. I won't explain every single detail because we don't have enough time, but the presentation describes each of these cases. The type of route leak already explains this quite well. And here you have the examples of each of these cases. So you can visualize this. This is a transit provider to another transit provider. What are the announcements that should be published and which would be generating a route leak from one peer to another? Then what publications should we make from our clients to the transit providers, which are all right, and also we have to deliver information to the peers of the segments of our clients, but this other peer should not be announcing the connection of its peer. So that is the information of the clients that are announcing the prefix 65001 to its other connections of the peer links, for example. And likewise, what it receives is a transit link. It has to be delivered to its client, the information that, but not to the connection with the ASN in the peering connection. So this is explained. I will be rapidly proceeding to explain
PC, que se le ref-
this other RFC, which is RFC 9234. This is a solution to a mechanism that we can implement in order to assign a role to a device in our infrastructure, to one of our routers that receives all the routing table. There we can, and depending on the role, determine what it should announce or not, and what should be allowed to go through and forwarded to other connections. So all this information of this role assigned to the device delivers the update messages and open messages that work in BGP. So they will know what is a role assigned to a device. And this, based on these roles, we then have the roles of each of these devices depending on the connection. You have the provider role, the client role, the route server role, the route server client role, and the peer role. I won't go into the details because we already know this, but based on those roles that you can assign to each of the elements, we then establish the peer relation. These are the only relations that should be established between the different roles. One assigning a role to these devices, and when establishing the connection, we have to check that, in fact, this relation is complied with. Only between provider and client, or client and provider, with route server and route server client, between route server client and route server, and peer. And if a different relation is established, for example, provider and peer or client and peer, then some type of action would be taken because this would be like a relation that could not be established. This role, or the assignment of that role to those devices, will be known under a new attribute, which is OTC, only to customer. And this is based on that attribute. it will see the role of that device. So depending on the type of relation, whether this is an acceptable or not, the connection is acceptable or not. Here we see the same thing with appearing links of 65,502 to its customers and to its peering link, and the connection to its transit. So between customer and provider, it is acceptable. Between peering and peering, it's acceptable. But the connection, for example, between the customer and the peering, this should not be acceptable between the roles or the relations that we have. And likewise, between the customer and the peering link. These links contain the information, so you can check out this mechanism. So when assigning some kind of attribute to the router, this will automate the process, and when we are aware of the type of role that the device has, this will then block it and won't allow one announcement to another to be forwarded. This is a case that occurred in 2004 between traffic exchange points from Canada, from France, that use this RFC regarding the roles. So we have an example of the ASN 54994 publishes a prefix to the traffic exchange point in France. This traffic exchange point in France implements the role RFC. It adds an attribute, in other words, only to customer prefix, and publishes that prefix to autonomous system 38040. It doesn't use the RFC. The autonomous system doesn't use this one, but the attribute continues along this segment, the one only to customer. And then that prefix reaches the other traffic exchange point of Canada that does the validation, and B, which is a prefix that is being published from a customer to a peer, to a transit provider, and blocks it over there because it sees that this is a segment that has the OTC attribute enabled. The step was not authorized, and that route leak could be blocked applying these role procedure, BGP roles. We had a lab to share with you to explain the use of these roles and how to automate this, but unfortunately we have run out of time. So if you wish to have more information about this regarding these roles, we can look at it in the course of the week. Guillermo, would you like to add anything? Well, in this lab, we had to set up the router in the middle.
And if we do not configure anything, everything that's announced can be seen by everyone. But then the idea was to have this router on client mode and the others on peer, and just play with those roles. When we have it on client mode, it will have everything and announce to the rest. But if we have this link on peer mode, as peering, it will not publish here what it learns from the vendor. So this is client, this is vendor, and these are learned routes for the vendor, and when it detects this is a peer, it won't be published. That's what we explained earlier about route leakage, learning from a vendor and publishing a peer. So with these roles, I know that this is my provider and this is a peer. So what I learn from the provider will have only for customer attribute and will be published to clients only and not peers or other providers. So basically it's what we wanted to show, but we run out of time. That's why we won't show it. And ASPA, very briefly, What it does, ASPA's purpose is to identify whether there have been breaches in the past. So what ASPA defines, each ASN will define, and this differs from ROAS, each one will define its providers with whom they have connections for transit. So, for example, right here, we can see AS1. AS1 will say that AS2 is the provider, AS2 will say AS3 is the provider, and AS3 will do the same with 4. So they are creating a chain with those peers, with those links, and then AS4 would be able to, if in this AS1, 2, 3, and 4 path, ASPA relationships have been established between each of the peers, then AS4 will be able to verify the path, and for the path to be valid in the database, it has to exist. This is an RPKI extension, not RPKI on its own, but since we have the resources and having now the ASN certificate, I will be able to say who are my providers. So this next one will say the same, and the next one will say the same. So then it is just a matter of determining whether the path, if in that path each provider said that the next one is their provider. So right here, AS1 has said that AS2 is the provider, AS2 has said that AS3 is their provider, and so on. So that allows us to check the full path. Basically, that's what ASPA does. It is a bit more complex when there is uploading and downloading. It is not that trivial because we need to check the upward chain and this one as well. And there could be cases where there are no ASP objects not being declared, like between 4 and 5. This is not yet an RFC, it's a draft that's being discussed. There's quite a progress being made. The registries already support, the RIRs already support these objects, but there's little adoption so far. So it is difficult to follow. It is, well, quite complex. This is not really widely used so far. This is not that interesting, but it is for you to see how an autonomous system can define all of the prefixes to be published. It's not the same as ROAS, but it is the ASN that will define all the prefixes to be announced, and that is another proposal up for discussion. So we have very briefly presented 2 RFCs and 2 drafts. Route leaks and roles are RFCs, are RFCs, and roles have been implemented in the routers. So if you check the routers, you can configure the roles directly, and that will automatically prevent most route leaks, and ASPA and RPKI prefix lists are still drafts under discussion and are more novel. Unfortunately, we don't have much time left. Is there a question? Okay, we'll have one more question. And our recommendation is to create the ROAS that have not yet been created. And well, let's open the floor for the question. Well, with those recommendations, Well, those are our recommendations, and to wrap up our tutorial, we will award the last prize. So we have the final question to ask you. Remember that you can come to the mic and provide your answer. And let me just show it so everyone can read the question. Well, as part of this last part of our presentation, we spoke about RFC 7908, where we explained this classification of the different route leaks. We show the 6 types available, and we've identified route leak cases. And we wanted to ask the following question. Out of these following cases indicated here, which could lead to a route leak? So we have A, learned routes that are learned from a peer and taught to a client. B, client routes that are shown to another client. C, route learned from a peer that are showed to a provider. From a peer to a transit provider. Or D, all of the above. Please come to the mic and tell us what you think. Option A, B, C, or all of the above. Well, we have someone here at the mic. Please, your name and your organization. My name is Samuel Santos from Newcomb Limited, and as a colleague said, I will just take a leap of faith, and I think it's D, all of the above. D, all of the above. So you've been tricked. Which one is the one that does not apply? Anybody else? And then we will explain why that does not apply. Anybody else that'd like to come to the mic? We have a prize here waiting for you. No, it's not D, it's not all of the above. Hello, Jefferson Calderon from Guatemala, from Barton Group. The answers, I think, are A and C. A and C. No, you were close, but nope. Hello, Kelvin Castro, Liberty Network. I'm sorry, what's your name again? Liberty Networks. No, your name. Nelvin Castro. I think it's C. C. Okay.
Vale, bueno. Muy bien. Sí, ganaste el premio. Esa es la correcta.
Yes, that is the correct one. Why? Because routes that we learn from a peer, yes, we show them to a client. That's true. If we have peering, actually, if it is a client we speak BGP. There are some clients which speak BGP, and that is not the end client. But yeah, we want to show them, because that's why we have peering, to resolve and reach closer with the organizations we are peering with. So the client needs to know that they can reach us through there. That is not a problem. Now, routes from a client that are shown to another client, well, that's okay as well. I have an organization where I have autonomous systems from a client, and I want them to know one another. I mean, these are our clients, so they need to know that the routes that I have and that the client A can connect to client B. So I have to announce it. The third one, yes, this is one of the cases that we discussed. If we learn from a peer, we don't need to send it to a higher provider, because in that case, I would have a transit loop that I shouldn't, or it's not necessary. So the one that could lead to a road leak is this. Peers that show it to providers. So Erica mentioned all of the cases quite quickly, but we had also discussed when we looked at route leaks. So we have a transit provider that announces something and we resend it to the transit provider, or from the transit to peer, or peer or peer to provider. So that should not be done. Now, peering to client, so client to client, or transit provider to client, yes. That's what the use of BGP rules can help us resolve. But well, of course, we could speak about this further, but unfortunately, we ran out of time. We adapted it a little bit to what you were expecting and the questions that were raised here on Zoom. And well, we prefer to look at what you were asking rather than showing more topics that maybe it's a bit overwhelming in the amount of information and not as useful. So that brings us to the end. Thank you for staying. I have some housekeeping messages. Thank you everyone for joining us this morning in our tutorial. We hope you are left with some, well, maybe food for thought or for some questions to be raised during the week. We'll be here all week if you wanted to review any particular topic. And another important thing to mention is that remember that everything we looked at today in theory will be applied in practice or more hands-on in the laboratory that we'll have this afternoon after lunch. So thank you everyone for joining us today. Thank you everyone. And I will, well, we have lunch now. So thank you again. So lunch will be right across the lobby next to the pool. We'll come back at 2 local time, 8 UTC for the hands-on lab. Thank you.